Today I'm going to present the smart dustbin for the group M. So without wasting time, let's get into the introduction. So these are group members. So our project is called the smart dustbin and it addresses hygiene issues related to traditional waste disposal in Bali. In many public and private spaces, dustbin still requires users to touch the lid, which increases the risk of spreading bacteria and viruses. Many people avoid touching the lid entirely, leading to open discs that smells bad and look unpleasant. This project proposes contactless solution by using a 68K microprocessor to automate the opening and closing of the dustbin lid using sensor input. This smart system enhances public hygiene, user convenience, and supports better waste management through simple automation. The next one is problem statement. The main problem we aim to is to solve hygienic nature of traditional dustbin. Manual lids require physical contact, which can transmit diseases, especially in hospitals, schools, or current system lacks automation and don't respond to real-time user interaction. As a result, they fail to provide a safe and clean environment. So our project consider this health and safety and environmental concerns that aims to develop a smart solution. That's all from me. Thank you.
Okay, my name is Surendran Ramchandran and I'm going to be talking about the objectives of our project here. The first objective is to simulate object detection using a binary sensor input. The second objective is to control an LED or actuator output, which will be representing the lid based on detection. The third objective is to implement the system logic, which is we will be using Motorola 68K assembly language. And the fourth objective is to test the logic and simulate it using IDE 68K. Okay, next I'm going to be talking about the scope of our project. The first scope is to simulate object detection using a binary switch as input. The second scope is LED represents the bin lid opening and closing. The third one is program written in 68K assembly language. And the fourth scope is tested in IDE 68K without real sensors or actuators.
Hi everyone, my name is Arvind Kumar Jaykumar and I'm here to explain about the programming and the simulation we did for this project. So this is the coding we used for the project Smart Dustbin, and before going deeper into it, I'd like to explain about the instructions first. So the first instruction that I want to explain is move.b, which is used to move or copy an 8-bit value. For example, we can move a constant like #1 into a register like do. And next is cmp.b, which is used to compare values. It doesn't store the result but updates internal flags and used for branching. And next up is bne. It's a conditional branch where it only jumps if the value compared are not equal. And BRA is an unconditional jump. It's useful for looping and it's very important for this project as we use looping a lot. And finally, EQ assigns a specific memory address to a label, like assigning 0110 to switch like we did in this project. So this makes the code readable and easy to update. And since I've explained to you about the instructions, I would like to explain to you about the coding. So this is the full code for the smart dustbin using 68K assembly. At the top, switch and LED are set to fixed memory address using EQ, and this helps us label hardware ports clearly. In the start label, we read the sensor value using move.b, switch do. So we compare it with 1. If the value is not 1, it means no object is detected. So we keep checking the branching back to start. And if an object is detected, which means the switch is equals to 1, we move the value to FF, which is 255 in decimal, to the LED. So this simulates turning on the lid like simulation, like opening it. And then in the wait object gone loop, we wait until the sensor becomes 0, which means the object is gone. So once gone, we send 0 to LED, simulating lid closure, and restart the process. And it keeps on looping, like we explained how BRA works in coding. So this is the coding simulator for our project, which is the smart dustbin, and I'm using 68K visual simulator to show you guys. And I've already configured the peripheral signals like switches and LEDs for coding. And we'll go step by step and show how this thing works. So first, it will read the sensor, and if the object is not detected, and the BNE makes it goes to the start, which means it's going in a loop and again and again. And let's say we switch on 1, which means the object is detected, and the object is detected, and you can see there is a change in FF here as it moved the signal, and also LED is working, which means the lid opens when this sensor is detected. And next, this will go in a loop again until the object is gone. So which means the switch becomes 0. Let's say the switch becomes 0 and the object would gone, and this LED stops, and you can see that the memory map, it becomes 00 again, and the process repeats again from the start.
Okay, now conclusion for this project. In this project, we developed a smart dustbin system that automatically open and close the lid when it detects an object. In this system, uses a simple loop continuously check input and respond real time. Throughout the simulation, the system worked reliably and showed how automation can reduce contact and improve hygiene. This project also gave us experience in real-time control and basic automation logic. So recommendation for this project, to improve the system, we suggest adding a relay so the lid opens longer. A longer motor can replace the LED to show real movement, and an ultrasonic will improve the detection accuracy. Using interpret instead of pulling would make the system more efficient. We also recommended adding a LCD display message like bin full or thank you to enhance user experience.